So once we've met our conditions, we have an estimator, that is the sample proportion 1 minus the sample proportion 2, that is distributed normally. And it is also an unbiased estimator, which means that the expected value, or the average of all possible values of P1 minus P2, is equal to what we're estimating, our parameter, where our parameter is pi 1 minus pi 2. Or the difference between the proportion of interest in population 1 and in population 2. And finally, the width of this sampling distribution can be described using the symbol sigma sub P1 minus P2. And our formula for the standard error of this estimator will be the square root of P bar times 1 minus P bar times 1 over N1 plus 1 over N2 So given this information, namely that we have a normally distributed estimator with a well-understood mean and standard error, in order to standardize, we simply need to shift this distribution to the left so that it is now mean 0, and then we need to rescale it by its own standard error so that it is now normally distributed, mean 0, standard deviation 1. Put another way, z test is equal our estimator P1 minus P2 minus the mean of that estimator, or the parameter that we're after, pi 1 minus pi 2, and in a test this will be our hypothesized difference, divided by the standard error of the estimator, P bar times 1 minus P bar times 1 over N1 plus 1 over N2, and take the square root of all of that. And P bar is our pooled estimate of the proportion, where P bar is equal to x1 plus x2, in other words, the total number of yes responses divided by N1 plus N2.